This is a video on improper integrals. The question is to find the integral from 0 to infinity of x e to the negative x dx. And I first use the definition of improper integrals when I have an infinity up on top. And what that says is we can turn that infinity into an m and then take the limit as m goes to infinity. Now to integrate x times e to the negative x, I'm going to use integration by parts. I'm going to let u equal x, dv equals e to the negative x dx. Then du is the derivative, or dx, and v is the integral. For the integral of e to the negative x, if I use substitution with u equals negative x, the du is negative 1 dx, and the negative comes outside, and I still have an e to the negative x. So next, I use the integration by parts formula. U times v is negative xe to the negative x. And then it says minus v du. Well, v has a minus sign, so minus a minus is a plus. And then I get e to the negative x times dx. So I could integrate that. And the integral of e to the negative x, I already did once, was negative e to the negative x. So there's the negative e to the negative x. Here's my x e to the negative x. And then remember, I'm taking a limit as m goes to infinity, and I'm going from 0 to capital M. So next I plug in capital M and plug in 0. And I've done that. Notice when I plug in 0, 0 times e to the negative 0 is just 0. And e to the negative 0 is 1. So the next step is to work out this limit. As m goes to infinity, e to the negative m goes to 0. So this term goes away. This part is infinity times 0, and that's one of our indeterminate forms. So I can rewrite all this as the limit as m goes to infinity of negative m over e to the m, and then a minus 0 minus 1 is the same as plus 1. Now when I plug in, I get infinity divided by infinity, and I can use L'Hopital's rule on that. The derivative of m is just 1, and the derivative of e to the m is e to the m. Now I plug in again. If I plug in infinity, I get 1 over e to the infinity, and that goes to 0. So I get 0 plus 1, and that, of course, is 1, and I'm done with the problem.